Hello, everyone. I want to take a second to recognize everyone who's here at 4 p.m. on a Thursday of a week-long conference. That is very exciting. Thank you for joining me. We're down the home stretch of the week. Hope everyone's had a great week. I'm going to walk through a couple slides before I do an intro, just to set some context, because the title of this session is Productizing Data Science with Tableau and AWS. But I'm going to double-click in an area that I don't think is talked about too much in the fashion world. So I'm going to give you a couple of tidbits here before we get started. So I've put some headlines up here of some of the recent buzz of data and AI in fashion. A couple to specifically call out. Sort of across the board, fashion companies are utilizing AI. Nike, for example, purchased a company called Select, which does inventory allocation modeling. So they're bringing operations in-house. There's one example which I really appreciate, which is there's an artist who did a design, basically a Balenciaga collection, by training a neural network on past collections and producing a full sort of runway-ready collection off of that model. So everything from operations to product design, people are starting to brainstorm ways of how to apply AI in that space. But it isn't just concepts, there's also real dollars behind it. So you can find a bunch of different research reports that say this industry is growing, but directionally it's all around rapid growth over the next few years. What I'm showing here is a 40% year over year to about 1.3 billion by 2024, and that's data in AI in fashion. And that doesn't even include the type of efficiencies and dollars realized from big fashion companies in-house. So why don't I segue into sort of the main concept of this talk, which is AI and ML democratization in fashion. My name is Dan Davis. I'm the Director of Product and Engineering for the datalabs group at Tapestry, and I'll tell you more about what that means. But just a quick background on myself. I've been at Tapestry for about a year and a half. Before that, I was with the analytics group at Amazon in the sort of brick and mortar space. Before that, I was at Microsoft, so big tech companies. But my main focus is building applications. So my team of full stack engineers works with our data science group to convert their models into actually usable, intuitive applications. So what is Tapestry? Actually, I had one conversation earlier where someone thought it was a totally different company. So let me do a quick intro on what Tapestry is. We're a fashion house based in New York. We own 3 brands, so we're sort of a portfolio of brands: Coach, Kate Spade, and Stuart Weitzman. You might have heard of those 3. We operate globally across the 3 brands. We do about $6 billion in total revenue a year. I included our mission statement at the bottom because I think it's a good way to think about how different AI and data in fashion is. The freedom to express who you truly are is the greatest luxury of all. Think about the creative process and fashion and art. There's a different space where we're applying AI and data science, and so it's unique challenges. And those unique challenges translate to our data. So we operate globally. We have over 100 million customers in our data set, and we're analyzing data consistently across different formats. So that's where the Data Labs group came from. And we're 4 main disciplines. We have a data engineering group. We have a data science team that's focused on the modeling aspect of it. Advanced analytics group, which is really about high-level consulting and working with each of the brands, and then my team, which is building applications. So that's who we are. I want to take you a little bit further on this transformational journey that we're on right now. This is something that we've been focused on for the last 2 years since I started at the company, and it's about transitioning to a data-driven decision-making organization, and that's really where applying data science and building applications came from. So I'll share with you sort of our internal view on how we do that. So imagine 2 organizations, A and B. One is what we call a non-data-driven organization. The other is a data-driven decision-making machine. In organization A, what I mean by non-data-driven organization, it's a company where decisions are made predominantly by humans and using some type of naive modeling. An example would be, in order to forecast what we're going to do this holiday, we're going to look at what we did last holiday in sales, and we're going to apply a 4% growth. And that's what our forecast is going to be. That's mostly done with a naive seasonality model and predominantly done by humans. In a data-driven organization, what we're trying to move to and what Data Labs is responsible for helping transition Tapestry to is how we augment human decision-making with AI and with intuitive applications that are our employees can use. In a data-driven organization, decisions are augmented with AI guidance. So that Black Friday forecast or holiday forecast, for example, is not just what we did last year at growth. It also says, hey, if it rains, people might not want to go shopping. So what is the weather going to be like during that week? And how does that weight into the particular forecast? It's also about processes. So how do you augment processes and how employees work with AI? In this case, how do we create a set of tools that makes people's lives better at their job, but enables them to do the things that make them uniquely human? And this is where, being in a creative space in fashion, our teams can do a lot of things that are uniquely human in the creative process. And so how do we take away a lot of the sort of boring processes that we can augment with AI? And the last one is, when we have all that technology together, how do we create a new customer experience? So how do we engage with customers in a new way using the capabilities that we've built? So we came up with 6 pillars. I won't walk through them all, but these are sort of the spectrum that we focused on when we thought about this journey. The 2 main ones I want to talk about today are the technology and the processes. And so what tools did we decide to build? And what processes did we put in place to help enable this AI-augmented culture that we're trying to build? I'll give you a quick glimpse into how data labs used to work, just for reference. Let's say a marketing team, for example, within Coach, wanted to know what the lift was of a recent campaign. They'd send an email to the datalabs at tapestry.com email alias with the question. The team would huddle together. They would decide what data they needed, what model they were going to run, and what the output was going to be. So we put it in a deck. Do we send an email back? Do we create a table for them to access? And that whole process, answering that single question, would take a week, 2 weeks, 3 weeks would go by. Competing priorities come up. Questions didn't get answered. So the first thing we needed to do was figure out a way to distribute analytics quickly and then create a set of self-service tools that our users could use to answer those questions quickly, not rely on us as a team to answer some of the basic questions. So we built this thing. We built the Data Labs web portal. We built a central repository for all Data Labs applications. And I'll talk more about what the applications are in a minute. But essentially, we decided to create a central place where any employee at the company could go log in using their single sign-on credentials and have access to the insights that we're producing and putting into our applications. Lots of companies do this already, but this was a new thing for us that Data Labs took on as an initiative, and it's really unlocked a ton of value. And the reason that I'm here today is to talk about how Tableau fits into that journey and this set of tools, this platform that we've built. So let me talk through a little bit of an example of how it would work. So this cool person in the glasses has a question, and she wants to know what type of customer is buying a particular new handbag. So we want to know more about demographics. We want to know about their purchase behavior. She's going to log into the Data Labs portal, and she's going to open an application. In this case, this is a Tableau Server sitting on an instance of AWS. We're hosting everything in an AWS environment. And so she's going to get access to that application centrally at this location. The great thing for us is, as a development team and because we own our data sources, we can publish and schedule all of our data sources. For those of you who haven't memorized the AWS icon library, that's Redshift. So our central data sources can publish to the data server. And our developers can publish applications, Tableau applications. The great thing about how we've set it up and being in AWS is it's not just the Data Labs team that can publish applications. Anyone else at the company who's using Tableau can also publish. We grant access to just about anyone who has a Tableau license. So we're quickly growing that user base. So I want to share with you for a second the benefit of using a central web portal is that we're not restricted to one particular technology or app suite. So I put a bunch of icons up here, but just to walk you through what our ecosystem looks like, and we're not just using Tableau as a visualizer, we're also using a bunch of different products as a part of that web portal. Our data science team leverages Jupyter Notebooks and hosts those Jupyter Notebooks in AWS to publish the endpoints to do things like rapid prototyping and sharing those endpoints with users. Obviously, Tableau we use for visualization. We have a team that does a lot of Google Data Studio. applications. So a lot of our GA data and ecom data sits in Google Data Studio, or in GA, and they use Data Studio to build applications on top of that. The web portal itself is a React app, so it's built in JavaScript framework. And then on the other side of it, we're using things like Kubernetes and Airflow to manage a full ETL process. So the web portal is really just the tip of the technology iceberg, really, and a lot of these services go into building that experience. The benefit, though, is that our developers can essentially develop in any language or framework that they're familiar with and publish to the same experience that the user gets at the end. So that's a big advantage for us in building a web portal is we have 20 engineers all developing in a mix of different technologies, and it all comes together in one fluid experience for users. So I talked about the web portal and the application studio. I'm going to show you what it looks like. This is the React app that I was talking about. One of the design challenges that we faced when we first were building this service is, as a creative company and with lots of creative talent, we wanted to build a minimalist, more intuitive product. So the applications sit behind these pretty simple cards. And like I said before, the view that you're seeing right now, and this is my homepage, a list of my favorite apps. To illustrate the point that I was making earlier, this application, Apollo, it's a Tableau app. It's really for customer and sales and transaction information. The one sitting next to it is a React app based in JavaScript, but it's a native web app that looks at customer type and other sales results. And this one's a Google Data Studio app. So again, we're sort of white labeling these applications and we're giving users this similar fluid experience without having to send them to different places. They don't have to have different accounts for any of this. That's all managed through one single service. So I'm going to talk more about the Tableau environment. This is our super custom Tableau homepage. We put our logo on there. But what we've done, because we have multiple brands, this is one of the data challenges that we face. We have multiple brands and multiple users across regions. And so data is restricted and partitioned based on the brand and the region. So we've set up an environment that each brand has its own site, and then user groups within each of the Tableau applications have their own access to regional data. This is for the back end folks in the room, this is a single node server. So a pretty straightforward environment that we've set up. We are moving to a multi-node cluster soon, hopefully, and that will help power some more of these experiences. So let's get to the data science part of this presentation. So how we use Tableau in our model deployment workflow. So this example is an EC2 instance. Let's say it's running a GPU optimized machine, and it's running a Jupyter notebook to run. For this example, we do a lot of vision analysis and image analysis. So let's say we're doing an image comparison or image labeling model. So that's sitting on an EC2 instance. There are really two outcomes with a model like this. One is we either convert it to a live endpoint, so maybe we'll build a Flask app on top of it, or we'll migrate it to something like a SageMaker instance or a Face Index or something like that. And it'll be a live endpoint that's accessible via an API. The other option is we create a static inference, or essentially a database labeling process, where it ingests some data set, it runs its algorithm, and then it spits it out into a data set that can be accessed by another application. So in the labeling instance, we're going to run our data set through the GPU machine. We're going to put it back into Redshift or another data source. For example, all of our React apps leverage RDS, so like a Postgres optimized version app database. And so we run our labeling through there, and we'll store data in the data set. And then Tableau Server will go and grab that data on a schedule. Our data scientists will build their workbooks, their Tableau workbooks, and publish them to the server, referencing those data sets. So it's a pretty straightforward, mostly automated flow. And so our data scientists are able to, essentially at full stack, deploy a data visualization on top of an existing model. So no Tableau presentation would be complete without some visualizations. So I wanted to give you a couple of examples of how our data science team is deploying those visualizations. On the left, you see a clustering view. It's essentially like customer clustering that we've done in the past. But this is an example of a Tableau app that's sitting on the web portal right now that's available for any user to come see how we segment our customers. And so this follows that same flow that I just showed you, where it runs through the model, it creates a data set in our Redshift table, and it publishes that to the web portal. Second view is a time series view, but a violin chart that just shows, again, like how we're able to publish these views for users to access. So looking forward a little bit, and this is the sort of the end of this part of the presentation, but we've got three main steps that we're focused on now. The first is adding more Tableau. So I mentioned before, moving to a multi-node cluster, and we're expanding our user base. So we have about 400 users right now, total across the organization. So relatively small, but that's growing quickly. We are expanding our modeling capabilities. So we're doing a lot of work on new models with new machines. A lot of computer vision, some video analysis, and some more sort of live inference. So for example, being able to serve up a recommendation on our e-com site. We can manage a live endpoint for that. And then new data, so new data formats, so ingesting third-party data, or the weather example that I used earlier, that's something that we're actively working on, where we're ingesting new data and augmenting our data warehouse.